Uh, Good afternoon. Thank you everyone for joining this session. Well, my name is Rafael Natali. I am originally from Brazil, but I'm currently living in Liverpool, England, where I work for a technology consultancy company called Marionete. Marionete is specialized in data and digital innovation with a strong background in the financial and insurance industries. Okay? I am working with Marionete for 5 years, since 2020, just before the pandemic starts. And I have been working with Kubernetes since then. Last year, I became a Kubastronaut. I had all the 5 certifications last year. And working, as we work mainly with regulated industries, security is always in the forefront of our projects, in the forefront of our minds in what we do. And why is that? It's because data leaks, threats, vulnerabilities are all over the place. They happen all the time. And Kubernetes obviously is not immune to that. And we need to take care of this. So with all this news and everything that we see happening in this scenario of threats, vulnerabilities, and fixes that we need to do, one can feel really overwhelmed. And we start thinking, what can I do about that? Where should I start? And I think that the best place to start is with industry benchmarks, patterns, frameworks, everything. So these are some of the examples. I'm pretty sure that we all are familiar with this: OWASP, MITRE, NIST, and so on. All of this, they have their particularities. They cover some specifics of what we can do, what we cannot do, the best practices for our work. The one that I would like to talk about today, the one that I have the most experience with, is the CIS benchmarks. It's something that we regularly do when we are in a new project and we need to start working with a Kubernetes cluster. So why the CIS benchmarks is a good benchmark? Why is that a lot of people use in the industry? So it is created by professionals in the industry, so it is recognized for the best practices. It has actionable and accountable topics and solutions that we can do. So you will receive a list of what are the recommended best practices and you can implement or not, depending on your system. And it's great for compliance and to consider if your Kubernetes cluster is production ready or not. You can use this as a basis. Yeah. So to start a little bit with the hands-on part. So how do we have access to the CIS benchmarks? Okay. We go to the CIS website. There is a specific page for Kubernetes, and in this specific page, we will have the list of all the benchmarks they have. So they have specifics for Kubernetes that you create on premises, for Amazon, for Azure, for OpenShift, and so on. All you need to do a registration in the website. Very simple. And with this registration, you will receive this, which is a 340-page long PDF, which is great, right? Awesome. Wonderful. So we just need to go by every single topic in the table of contents and check in your environment if you need to fix or not. See? Simple. Right? You can just do this. Okay. This is great as a reference, but that's not very practical if you really want to do this in your environment, right? Not even if you want to send this to the trainees you have. So what do you do? There are tools around that can help us to run the checks in your environment. One of those tools is the Kubebench. Kubebench is a tool from Aqua Security. Okay. And it's not showing. Why? Sorry. Okay. Sorry. Okay. So, okay. Kubebench is a tool, as I say, from Aqua Security. Just let me, sorry. Go back a little bit. What is? Okay. Okay, thank you. Again, we use Kubebench as a tool. We can install this tool. There are several ways to install. You can install as a binary, so you can run from the command line. You can install from the source. There are several ways to install this tool. And what Kubebench does is it has all that information that we can see from the PDF. It has everything stored, and it will run, and it give you a report of what is the status of your cluster. Okay, here they provide you with example of a Kubernetes job that you can run on your cluster, and it will execute the Kubebench and give you the report without you having to install any tool in your cluster or anything like that. Okay, this is the example that I'm using. I'm installing from the job. So this is my cluster. I have a very simple cluster, just with a control plane and a worker. And I will install the Kubebench job based on the example that we have in the website. The only thing that I'm changing is this part here for the command that I am including to check the master, to check etcd, to check the nodes, and to check all the policies. In the example they have in the website, it's just the master. So I'm including all the possible outputs for the tool in this example. Okay. So, as this is a Kubernetes job, the only thing that we need to do is to deploy in the cluster, and it will automatically create a pod, and it will execute the Kubebench, and we'll be able to see in the logs of the pods the report of the cluster. So this is a cluster that I created from scratch. This is running on a virtual machine, it's not Azure or AWS. It's a cluster that I created in a Linux server. So it's the 1.30 version of Kubernetes yet. So now I deploy the job, creates the pods, it will run the kubench as you can run if you install the CLI running kubench and the targets in this case. Okay, it runs for a couple seconds, and when it finishes, we will be able to see the logs. Okay, so it runs for about 30 seconds and completed. And in the logs, we will see the output for my cluster. As I said, this cluster I created from scratch. There is nothing running, so it's a brand new installation. And we can see here, we can see a lot of information. So it runs all that checks that we have in that page, in that PDF, and we can see here. So it has 5 components. So the first one is the control plane security configuration, and it shows here on the left, we can see that if we pass, or if there is a warning for something, or if we fail. Warning is usually something that is recommended, but it's not considered a must. So it's just a warn. So if you want to do, it's a good practice. And you have some fails, and when something fails, it's something that is considered wrong, and it is recommended to fix. And just after each session, it shows the remediation of each of the topics with a warn of a fail. So for example, the 1.12, which is a permission issue, etcd data directory does not belong to the etcd user. This is recommended. So it shows how to fix. So it gives you the report, it gives you the warning, the fail, and just afterwards show you the steps to fix. All of this information is the same recommendation that you will see in the PDF file, but you don't need to go step by step and do manually. You can use the tool and verify everything. So for etcd, for example, we pass all the examples. For the workers here as well, we have what we pass, what we didn't pass, and the remediation just after. And the same for the Kubernetes policies. This is RBACs and service accounts. It also shows you. Yeah, if you just want to check your master in the job, you can just change the targets to only master or only node or only etcd. I'm checking master here because I am this is a Linux machine I created. So, but if you are running, for example, in AWS or any managed server, you will probably not have access to the node to check the node. You will only check the master, the master or the control plane. You will need to check the nodes or the etcd. So for this brand new installation that we did, we can see that we have 61 checks that pass, 17 checks that fail, and 47 checks that are a warning. Okay. The next step is to fix one of these problems. And for example, we can fix this one for the etcd. So as we did the execution of the kubench, it returned the results, and we saw that we have a problem with the ownership of the etcd directory. Okay, so this is the 1.1.12. The recommendation is to ensure that the etcd data directory ownership is set to etcd, user and group etcd. In the remediation, we have the steps to remediate. They are fairly straightforward. Just change the ownership to etcd for the var lib etcd directory. Okay, so that's what we are going to do here. We are going to change this. And it gives you even the commands. So if by any chance your etcd is installed in a different directory, you can do the ps in the process of the etcd, check the data there. So we are using the var lib etcd. So we need to change the ownership of this. Okay, just to double check, I'm checking the ownership of the etcd today. So just after the installation, as I install as root, the etcd belongs to the root user and the root group. I already have the etcd user created in this Linux. So I will just execute the command that was recommended, which is the chown to change the ownership of the etcd, of the var lib etcd. Again, double check if the permission was changed correctly. The one. Okay, now it changed the ownership. As we change the ownership, the next step is to run the tool again, just to double check if that specific case was solved. As I'm running as a job, I need to delete the job, reapply the job. This is going to restart the pod. It will run the application. It will, in this case, you rescan everything again. So it's not, if you're just changing one thing or two things, maybe you don't need to run this all the time. You can do a series of changes and then check if everything's okay. In this case, just for demonstrations, I will do this one. Okay, and again, it will run, redeploys. Yeah. And after it runs, we will check the logs again and see that is considered fixed or not. Okay. This is something that we usually do after we install the cluster the first time, or something that we do when we are in a new project and we are going to start supporting a cluster that was installed by some other team or by somebody else, which is important to understand what and where are our vulnerabilities, what has not been done, what can be done to improve the security of a cluster. So now it's completed, and then we can check again in the logs, and we will search for the 1.1.12 vulnerability. It's not this one. It's not this one. It's 1.2. It's fine. And yeah, 1.1.12 now is passing before it was failing. Okay. So now we have fixed one vulnerability for our control plane. Okay, and we can do the same steps or similar steps if you need to fix something for our nodes. Okay. So here we are going to check the logs for another vulnerability. So this one, for example, is to ensure that there is no profiling in our control plane. So this is for the Kube API. So the recommendation is to change the controller manager arguments and include profiling equal false. So let me just clear the screen. Okay. So as the kube controller manager is a static pod, just do a backup. Never hurts. And in the controller manager, in the comments, we are going to include the recommended change with the profiling equal false. So we are not going to allow any kind of profiling in our cluster. Now, the kube controller manager as a static pod, when we change, it's going to restart the pod in the kube system. So this is what's happening now. It terminates the old one, which didn't have profiling enabled, and now it's recreating with the profiling enabled. Oh, profiling, actually, sorry, it's the other way around. The old one didn't have profiling as enabled, and now we put it false. Okay, it did the kube controller. So again, delete the pods, delete the job, rerun to make sure that the Kubench is going to recognize the solution as completed. Okay, it's running again. Okay. And we're going to check the logs just to see if now the profiling is considered resolved or not. Okay. Okay. And we go back, yes. And now the profiling is set to false, which is the recommended approach. Okay. So, okay, perfect. So the CIS benchmarks, again, is created by industry, is something that has the best practices and recommendations that we can use for a Kubernetes cluster. It's very straightforward in what it suggests and the recommendations. You can really you can put this if you have, for example, you can create automations that already include some of these fixes. So when you create a new cluster, you need to go there and fix the same things all over again. So you can already have this already fixed. You can really measure your progress through the recommendations. You have the reports with the amount of failed and passes and warnings that you have. So you can really show the progress in what you are doing. Okay. And that's it from my end. Just show a little bit about the CIS benchmarks. Thank you very much. In this QR code, you have some of my contacts and access to a GitHub repo where I show the installation of the cluster that I did and the executions of the Kubench in this cluster as well. Thank you very much.